Hello everyone. Hello everyone. Good afternoon all of you. Good afternoon everyone. Please give me confirmation my audio and video is clear so that we can proceed with today's session. Hello everyone. Good afternoon. Please give me confirmation regarding audio and video. Is it clear? Hello everyone. Good afternoon. It is clear now? Okay. Now, a very warm welcome to third session of your Agri 360-degree series, and in today's class we will be discussing in one of the hot topic nowadays in many of the competitive exams, that is your precision farming and remote sensing. Okay, so for today we have a very interesting topic, that is precision farming and your remote sensing. Now, let's start with precision farming. What is the exact meaning of precision farming? See, precision. The word precision means preciseness, accuracy. So when you are bringing accuracy in your farming practices, accuracy in your farming system, such kind of your farming is known as precision farming. Okay. Apart from that, properly we can define it as precision farming is a kind of information and technology based farming system in which we are using present data, present tools and techniques, different tools and techniques to bring more preciseness and accuracy in a farming system, which has many benefits. Precision farming focuses on reducing the waste and making the best use of the resources available, means optimizing the use of resources and giving us the best result, the best output without any negative impact on the environment. That's the concept of precision farming. Okay, now see the definition. Precision farming is an information and technology based farm management system to identify, analyze and manage variability within the field by doing all practices of crop production in right place at right time and in right way. Yes, the 3 R's. Okay, basically the precision farming follows the 3 R's: right place, right time and the right way. Precision farming says that our soil, okay, our agriculture land is not of homogeneous in nature. Okay, understand this, huh? Our conventional method of farming, means the chemical based farming method which is being practiced since years now. Such kind of methods, conventional method considers soil as a homogeneous nature, means each and every place, each and every corner within the field has the same characters, same nitrogen, same phosphorus, same moisture level. This is the philosophy of my conventional farming system. But what precision farming says? Precision farming considers soil as of heterogeneous nature. Heterogeneous nature means that each and every place is different. Soil is different. Soil is different means the characters of soil. Each and every corner does not have same nitrogen, same moisture level. So if we have different characters of soil within the farm, then why we are applying a uniform application? Then why we are applying each and every corner of the farm the same resources? That's the fact and that's the key concept of the precision farming. Precision farming says that it's very necessary that we need to identify the characters of each and every corner of my soil. Okay, apart from that, analyze each and every character and then accordingly you have to manage the variability. Yes, means see, if one part of my field requires more nitrogen, then I will be applying it more, and if any one particular part has sufficient amount of nitrogen, then I will be avoiding it. And same goes with the other resources as well, like water, micronutrients and other inputs too. Okay, and then we can bring more preciseness, more accuracy in a farming system, right place, right time and in right way for optimum profitability, sustainability and protection of the land resources. Now, see, definition of precision farming is very important. We will be practicing PYQs as well now. So, and it was asked in NABARD 2022 as well as AFO 2025. Okay, it was asked in NABARD 2022 and AFO 2025 as well. So that's the concept of precision farming. Now, let's talk about precision farming. Includes all those steps. So basically, what are the steps? What are the requirements of precision farming? See, precision farming has 3 requirements. Okay, there are the 3 requirements of precision farming. The very first, you need to identify the each field location. Okay, you need to identify the each field location. See, by every field location, what is the meaning? Suppose this is a farm. Okay, this is a farm. So precision farming says that soil is of heterogeneous in nature. Soil is of heterogeneous in nature. So definitely this part, okay, has different character. This section has different character. This section has different character. And this section has different character. So we need to very first identify the each field location. That if I talk about this small grid, then this particular grid will have different characters as compared to the above grid. So the very first and the crucial requirement of the precision farming is that we need to understand, we need to identify the each field location. Then we need to capture, intercept and analyze the different agronomic data, different agronomic characters of this soil, and then accordingly adjust the input use. Okay. Then adjust the input use and farming practices to maximize the benefit from each field location. Okay, so these are the basically 3 requirements of precision farming. Next, benefits and limitations of precision farming. Okay, like in the previous session we discussed about organic farming, remember na? So organic farming also has some perks and some challenges or limitations. Similarly, precision farming also has benefits as well as some limitations too. Now I need answer first of all from your side. Can you tell me what are the benefits of precision farming? Come on everyone, what are the benefits of precision farming? Come on, give answer for this. Come on everyone, I need answer from your side. Very simple question. What are the advantages or benefits of precision farming? Now, see, the very first, it is important, it was asked in AFO 2025 exam, RRBSO 2021 exam, and FCO 2025 exam as well. So these benefits of precision farming is important. Now, see these points. The very first, target based. Okay, what is the main perk or the main advantage of precision farming? It makes the best use of the inputs. And when I talk about best, it doesn't mean the use of inputs excessively. No. It means in a very effective way. It optimizes the use of inputs, because since we are bringing variability within the farm, definitely we are using inputs according to the different requirement of my different places in a field. So the very first benefit is the target based, more effective use of the inputs. According to the requirement, we apply inputs in the field. So definitely it is an advantage. Why? Because we are reducing the wastage of input and hence cutting down the cost of input as well. Increase productivity and profitability. Yes, now see, when you use precision farming for a longer time, it's not for initial time or for a shorter duration, no. If you are using precision farming for a longer time, definitely it will increase the yield and you will get better production, hence resulting in a better profit. Optimizes resource use to improve the crop yield and reduce the operational cost. And yes, the operational cost reduce as well. Why? Because we are cutting down the cost of input. We are not using anything excessively or in a uniformity. That's why definitely we are cutting down the cost of production that is spent on the resources. That is spent specifically on the resources. And when I talk about resources like pesticides, insecticides, herbicides, fertilizers, that's the meaning. Now, environmental sustainability. Okay, what is the meaning of environmental sustainability? Since we are cutting the inputs, means we are reducing the usage of chemical based products. So definitely now it is good for environment comparatively as compared to the conventional method of farming. Reduces the waste of water, fertilizer and pesticide, which minimizes the chemical runoff and greenhouse gas emission. Then improve decision making. Yes, see, when we have data, when we have practical proofs, when we have proper data, when we have proper yield, we have each and everything in a very strategic manner, okay, then definitely the decisions are better and you can make a better right choice. Provide farmers with detailed data and decision support tools for more informed management decisions. Then next, limitations. Definitely we have limitations as well with precision farming. So what are the limitations of precision farming? See, the very first, high initial cost. Definitely the one of the major limitations of precision farming, that initially you need a very good amount of money, very huge amount of money for precision farming, because the tools like GPS, GIS, or even if I say a simple computer, tell me, is it cheap option? No, it is expensive, and definitely for the farmers. We know the farmers, our country mostly has small and marginal farmers. The farmers, their financial conditions are not that good. I'm talking about different states. No, see, the states like Punjab, Haryana, even Uttar Pradesh as well, comparatively the farmers they have a good stable socio-economic conditions, but some other states like Jharkhand, Chhattisgarh, and specifically the farmers of arid and semi-arid areas, definitely their financial condition is not good now. So how is it possible that they will be able to go for GPS, GIS and such kind of technologies? They don't have enough money for that. And requires the skilled labor and technical expertise. Is it easy for handle a drone? Tell me, is it easy to handle a drone? Even I won't be able to fly a drone. You won't be able to fly a drone. Why? Because we need a proper training for that. Definitely. Na? Similarly goes with the knowledge of proper GPS, GIS and other tools and techniques as well. We need a proper knowledge, skills for handling all these tools and techniques to gather the information to make the best use of these resources. But we definitely know that there is a long bridge between the farmers and the technology. So definitely the farmers need to be educated more. More extension work is required for building their skills with respect to precision farming. Then low digital literacy among the farmers. Definitely still the farmers are not able to properly use the touch phones. Is it true now? Still the farmers are not able to use properly the touch phones that are very common nowadays. So how are you imagining that they will be able to handle the computer, GPS and other sensors? Practically not possible currently. So definitely we need to improve the digital literacy among the farmers so that in future they can switch to precision farming. Then poor internet connectivity and power supply in the rural areas. Now tell me, electricity is there 24/7 or not? In majority, I'm talking about the rural areas specifically. Why? Because agriculture is related to rural sector. Is there electricity 24/7 in the rural sectors? No, not basically. I'm damn sure whether it's rural areas of South India, North India, Central India, none of the village would have electricity 24/7. Not possible. So tell me, and the data, internet connectivity as well. So without proper internet connectivity, without proper power supply, how is it possible to handle the tools and techniques of basically precision farming? Not possible now. So another limitation for precision farming, small and fragmented land holdings reduce the cost effectiveness. Now see, precision farming, yes, it is definitely a very good option, but it is only meant for the large farmers. And our country consists of more small and marginal farmers rather than large farmers. So definitely it won't be beneficial for them. So another limitation. And high maintenance and repair cost of the devices. Definitely it has high initial cost, but apart from that, you need a proper maintenance cost and repairing cost as well. It will also take a good amount of money. So these are the basic limitations with the precision farming, and because of that only in our country precision farming is not that popular. Now let's talk about the tools and techniques of precision farming. Okay, what are the tools and techniques of precision farming? The GPS, GIS, drones, grid sampling, VRT, remote sensors, proximate sensors. These are the few tools and techniques used in the precision farming. The very first we have, and yes, the important for your, whether you are preparing for your any banking exam, whether you are preparing for your MSc entrance exam, or even you are a student of university in your first year, second year, precision farming definitely an important chapter, important part of agronomy. So you can make your graduation notes as well from these PPTs. Now see, the very first we have GPS, that is global positioning system. Now tell me, what is the use of GPS? GPS, this feature is present in our phones as well. True now? What is the purpose of GPS? GPS is used for mapping, for locating purpose. True, GPS is used for mapping different locations within a farm, so that further using other tools and technologies we can bring variability within different places. So how I will be mapping these different places? Using the GPS. Okay. Now GPS is a set of 24 satellites. Remember this, huh? It is a set of 24 satellites in the Earth orbit. GPS allows the precise mapping of the farms, and together with appropriate software informs the farmer about the status of his crop and which part of the farm requires what. Okay. Now, father of GPS, Roger L. Easton. Who is considered as the father of GPS? Roger L. Easton. Now, GPS satellite revolve around the Earth twice a day. Okay, it revolves twice a day and in a very precise orbit and transmits the signal information to the Earth. Now, another important points and facts about the GPS. The number of orbits available in the GPS system is 6. Okay, the number of orbits available in the GPS system is 6 and the total satellite is 24. Remember that, huh? The GPS satellites are fixed at a distance of 20,200 kilometers. Important. This is also important and this is also important. GPS, it has 3 segments. Space segment, control segment and the user segment. The whole set of GPS satellites is known as Constellation. Okay, the whole set is known as Constellation. Now, GIS, Geographic Information System. Now basically this is a software tool. Okay, GIS is a software tool, and with the help of GIS only the farmers are able to store the data, to analyze basically the data with respect to different factors within a farm. GIS is a software tool that enables farmers to store, analyze and display the spatial data such as the field maps, soil samples and weather data. Who is the father of GIS? Roger F. Tomlinson is considered as the father of GIS. A GIS contains input, output, database and analysis. Then next we have grid sampling. Now what is the meaning of grid sampling? See, grid sampling, let me explain you with the help of a diagram, it would be better. I am making 2 farms. Okay. Here I am making 2 farms. This is farm A and this is farm B. In farm A, I am practicing precision farming. Okay, in farm A, I am practicing precision farming, and in B, just my chemical based, completely chemical based conventional farming. Okay, in the farm B, I am practicing the conventional farming. So, if I have to do soil sampling, then in my conventional farm, that is farm B, what I will be doing? I will be going for the zigzag method. Okay, I will be going for the zigzag method of soil sampling. But in my A farm, where I am practicing precision farming, what I will be doing? I will be dividing my farm A in grid boxes. Okay, I will be dividing my farm A in the grid boxes, the grid size is on an average 0.5 to 5 hectares. Okay, it is 0.5 to 5 hectares. And then from each and every grid, from each and every grid, okay, I will be taking the soil samples from each and every grid. I will be taking the different soil samples, and then I will be sending it for the testing purpose. This is known as the grid sampling. Why? Because in precision farming, we consider soil as of heterogeneous nature, not of homogeneous nature. Na? So definitely, I will be taking soil sample from each part of the soil so that I can get to know the variability, or basically the different characters of the soil. Okay, that is known as your basically grid sampling. It is a method of breaking a field into grids of about 0.5 to 5 hectare. Sampling of soil within the grid is useful to determine the appropriate rate of application of fertilizer. Several samples are taken from each grid, mixed and sent to laboratory for analysis. Okay. Then VRT, variable rate technology. Now see. This allows farmers to optimize the use of inputs and reduce the waste. Okay, VRT, variable rate technology. By using this technology only, we are bringing variation. We are bringing variability within the farm by using this technology. Okay, and because of this method only, we are making the most optimized use of the inputs and hence reducing the waste. Now, VRT, the existing field machinery is added with the ECU. What is ECU? Electronic control unit. It acts as a brain of a machinery. Okay, this ECU acts as a brain of the machinery and which gives command, and it has GPS as well. Now GPS will locate different places within the farm. This particularly ECU, with the help of GPS, gives command to the field machinery, and then variable rate application with respect to the input is maintained. Okay, that's the concept of your particularly VRT. Then next we have the yield maps. Now see, what is the meaning of yield maps? Yield maps are basically your result, your feedback, the final response. That, see, I have done a lot of basically I have done a lot of hard work in soil sampling. Why? Because in place of random or zigzag soil sampling, I opted for grid sampling. I have done sampling from each and every block, then further sent for the soil testing, then using variability techniques as well, that is VRT. So tell me whether I am getting a better yield or not. How we will identify this? We will identify using the yield maps. Okay, we will identify this using the yield maps. Yield maps are produced by processing data from agriculture machines integrated with our yield recording system. Yield mapping involves the recording of the grain flow through the combine harvester while recording the actual location in the field at the same time. Okay, so basically it will record that from each different place how much yield is obtained. Okay, from each different place within the farm, how much yield is obtained. That's the function of yield maps. Next we have the remote sensors, very important. Okay, what is the meaning of remote sensors? Remote sensors are meant to detect the energy that is reflected back from the earth, that is known as albedo. Okay, what is the meaning of remote sensors, or what is the purpose of remote sensors? Remote sensors are meant to detect and capture the energy, the light that is reflected back from the earth's surface, known as albedo. And remote sensors provide us all the data about a particular surface. It could be any land, forest, any glacier, and other factors as well. We will be discussing in this session only. And it provides us aerial images as well, which can be used for further monitoring purpose. So that's the purpose of remote sensors. Remote sensors gather data by detecting the energy reflected from the earth. These sensors can be installed on satellites or in aircraft. They can indicate variations in the color of the field that corresponds to changes in soil type, crop development, field boundaries, water, etc. Aerial and satellite imagery can be processed to reflect the health of the plant. Okay, and yes, using those satellite aerial images, we can monitor the crop, we can look for the plant, like what is the intensity of the pest disease or any kind of a weed attack. Okay, and we can monitor the plant health as well. So these are the perks of remote sensors. Next, we have the proximate sensors. See, the functioning of remote sensors and proximate sensor is exactly the same, but what's the difference? Proximate sensors are specifically used to capture the data from a closer distance. Remote sensors are quite stay distance from basically the top articles or the targets, but in case of proximate sensors, it is very close to the surface, placed in close contact with or near the soil crop within the meters. Gathered again the data, real-time data, soil properties, crop growth, and enabling the automated machinery for precise seedling, fertilization, irrigation. Okay, each and everything can be done using the proximate sensors. Why? Because it will provide more precise data from a close contact rather than the remote sensors. Okay. Now, next we have drones. Now, when I talk about drones, drones are also known as the unmanned aerial vehicles. Very advanced sensors that has camera as well, whose purpose is to collect the real-time field data. Okay, what is the purpose of the drone? Drones have cameras as well, which will provide again the aerial images and the present real-time data too. Drones are used for spraying purpose. Drones are used for the spraying purpose, and even drones are used for photography purpose. Drones are used for the spying purpose as well. So there are many different uses of drones. Collect real-time field data for efficient data-driven farming, enabling tasks like detailed crop monitoring, early pest detection, optimized irrigation, precise pesticide spraying, seeding, and soil analysis, ultimately boosting the yields while reducing the cost and labor. These drones improve the resource management by targeting the specific areas, leading to smarter decision and better crop health compared to the traditional method. Okay, so this is the benefit of the drone. Next, computer hardware and software. Definitely the tools and techniques to run them smoothly. We need the hardwares and the software as well. We need the computer, we need the CPU, true, and we need the optimum software as well to analyze the data in a more simplified form. The language that sensors speak the normal human being won't be able to understand. So definitely we need the sensors to convert those typical data, complex data, into a simplified form of chart, table, pie, graphs, okay, which is obviously done with the help of hardwares and software. Okay, so another important tools and technology required for precision farming. Done. Now, let's start with the remote sensing. As I have already told you, what is the meaning of remote sensors or what is the purpose of remote sensors? See, remote sensors are meant to capture or gather the data by the use of electromagnetic energy. Okay, by the use of electromagnetic energy, the remote sensors capture or gather the data about any particular location or about any particular object. Use of electromagnetic energy to determine the physical characteristics of distant objects without being in physical contact with them, without touching them. From a very distance only, the remote sensors can gather data about different objects. Now, it comprises photography, geophysical surveying. It uses newer techniques with other areas of the electromagnetic spectrum as well. Okay. Now, the types of remote sensing. So, we have two kinds of remote sensors, passive sensor and the active sensor. Okay, so we have two kinds of remote sensors, passive sensor and the active sensors. The very first, let's talk about the passive sensors. See, remote sensors definitely need a light, electromagnetic wave. Now, definitely they need an electromagnetic wave. Using that only they will be able to capture the data about any particular object, location or any surface. True. So the very first we have the passive sensors. Passive sensor completely depends upon the external source, external stimuli. Means, see from this figure. What happens? This is sun. Okay, this is sun. when sun emits the light, okay, when sun emits the light, some part of the light is absorbed by the surface while rest of the part is reflected back. True na? Some of the part of sunlight is absorbed by the surface while the other part is reflected back. Reflected back. And you know, the reflected back sunlight, the reflected back radiation is known as albedo. Okay, the reflected back light is known as albedo. Now, the remote sensors, specifically the passive sensor, I'm talking about the passive sensors. Passive sensors basically collect, they capture, or they respond to this albedo, and then they gather data about that particular object. Such kind of sensors is known as passive sensor, which don't have their own energy, which don't have their own light. Okay, they completely depend upon the sunlight, they completely depend on the external stimuli, they completely depend upon the albedo for gathering and capturing the data about a particular object or a location. Okay, such kind of sensor is known as the passive sensors. Respond to external stimuli, measure natural energy that is reflected or emitted from the Earth's surface. And remember this point, albedo is used in passive remote sensing. Most prevalent type of radiation measured in is reflected sunlight, that is known as your albedo. Now remember one thing when I talk about passive. P stands for photo, and photo means light. So the remote sensing that depends upon the external light is known as passive sensing, or the sensors are known as passive sensors. Okay, remember this. Now the next we have is the remote sensing. The active sensors, active remote sensing. What is the meaning of active remote sensing? Now these kinds of sensors do not depend upon the external stimuli. They have their own internal stimuli. Okay, they have their own internal stimuli. They don't depend upon the albedo for gathering the data about a particular object. Now what happens? They have their internal stimuli, means they have their own laser beam. They have their own laser beam, and that laser beam is basically targeted on a particular object, and then definitely they capture the data of particular object or a target. Such kind of sensing which has its own internal energy, own internal laser beam for gathering the data, for capturing the data. Such kind of sensing is known as active remote sensing. Okay. Collect data about the Earth by detecting the internal stimuli. Example, a laser beam remote sensing system shines a laser onto the Earth's surface. Measures the time it takes for the laser to reflect to its sensor. And you know what? Such kind of sensing, the active sensing, is very beneficial specifically for those areas where sunlight is not optimum. Okay, like the dense forest or basically polar regions which do not get the optimum sunlight. So for that region specifically, active sensing is very good option. Now some other important points about the remote sensing. The term remote sensing was first used in the United States in the 1950s by Miss Evelyn Pruitt of the US Office of Naval Research. The father of remote sensing in India is P.R. Pisharote. Indian Institute of Remote Sensing is situated at Dehradun, Uttarakhand, and was established in 1966. The headquarters of National Remote Sensing Agency is located in Hyderabad. Space Application Center SAC is located in Ahmedabad, Gujarat. Aryabhat is India's first satellite and it was launched in 1975. Okay, it was launched in 1975, and IRS-1A was the first Indian remote sensing satellite. So these are some of the important points. Apart from that, if I talk about the uses of remote sensing, what are the uses of remote sensing? Definitely it is used in the agriculture for the crop identification purpose, for monitoring purpose, okay, for keeping an eye on a farm so that each and every activity can be properly tracked and monitored. Then yes, definitely it is very important for tracking the coastal areas as well, for mapping the coastal features and to prevent it from erosion. Then ocean, definitely the ocean circulation, the current systems, okay, to measure the temperature, to track the glaciers. Remote sensors are very good. Hazard assessment, yes, Remote sensing can also track the earthquake, hurricanes, tornadoes, or any kind of natural hazard. Okay, so we can get advanced alert for all these kind of natural hazard by the help of remote sensing. Okay, for the natural resource management as well, like for identifying the wildlife habitat, for mapping the wetlands. Okay, for looking at the environmental impacts, definitely remote sensing helps us. Weather forecasting, yes, definitely the weather patterns, the precipitation, temperature, change in the humidity, all these factors of weather phenomena can definitely be, we can get the information forecasted in advance by the help of remote sensing. Then environmental, yes, it has many environmental benefit. The atmospheric models employ remote sensing data. By using this, we can definitely get to know the hotspot areas of the greenhouse gas emission. Yes, so basically those areas from which the greenhouse gases are emitted maximum. So all these data can be definitely gathered and captured by the help of remote sensors. Now, Indian remote sensing satellite. The Indian remote sensing satellites are the mainstay of the National Natural Resource Management System, okay, for which the Department of Space is the nodal agency, providing operational remote sensing data services, and starting with IRS-1A in 1988. ISRO has launched many operational remote sensing satellites, and like the latest one, these are those satellites. Okay, these are the latest satellites we have. Definitely the satellites launched in 2026 is important for you. Apart from that, the 2025 ones as well. Now, the very first we have is the Anvesha EOS N1. Launch year is 2026. It is a hyperspectral Earth observation strategic surveillance, basically satellite. NVA-02, its launch year is 2025 for navigation purpose. Then NISAR, very important, NISAR is very important. It was asked in JRF Agronomy as well. 2025 is the launch year. And what's the best thing about the NISAR? That it is jointly developed by the ISRO and NASA. Okay, it is jointly developed by the ISRO and NASA together, which has S-band as well as the L-band. The very first joint mission of ISRO and NASA. The purpose is the Earth observation, and it will provide data about each and everything for the forest, crops, glacier, urban mapping, each and everything. The data can be given by, NISAR. Then we have GSAT-7R 2025 for the communication purpose. Specifically, it is useful for the Indian Navy. Then the Bluebird Block 2 2025 again is the launch year, and communication for mobile broadband payload. Then we have INSAT 3DS 2024 is the launch year. Purpose, meteorological purpose, or we can simply say for the weather monitoring purpose. Then we have ExpoSat 2024 is the year for X-ray astronomy, space science observations. Okay, now ready for the quiz? Here we wrap up the concept part. Now let's practice some of the PYQs, and I need answer from each and every one. Okay, give answer for this. Come on. What will be the answer? Everyone. Give answer for this. All of you, it was asked in AFO 2025. Consider the following points regarding the drone technique in agriculture. What will be the answer, everyone? Okay. Option number B. Here the correct answer is option number B, which says it eliminates all the pest population. See, using drone, eliminate means the 100% removal. The very first thing, eliminates means the 100% removal. Tell me, the 100% removal of a pest, definitely you should choose the most best pesticide first of all. So the 100% elimination depends upon the pesticide, not on the drone completely. So definitely this point is wrong here. Crop monitoring can be done. Yes, definitely reduces the fertilizer use. Yes, why? Because we can bring preciseness using the drone. and application of pesticide. Yes, it is used for the spraying of pesticides, so definitely it is a benefit. So here option number B, 2, 3 and 4th point is correct. Next question, asked in NABARD 2022. Give answer for this. What will be the answer? Okay, good. It's definitely option number B, precision farming. Simply asking about the definition based question. Now, next, arrange in correct sequence the steps of precision agriculture. It was asked in JRF Agronomic 2022 as well as 2025. Give answer for this. What will be the answer? Everyone. What will be the answer? Come on. Okay, good. Option number B is the correct answer. So if we arrange it accordingly step by step, then definitely the very first is to assess the variability. You have to assess the variability. Then accordingly, you have to make the preparation of the variability map. Then you have to imply that, manage the variability, and then last is the result time, evaluation of the precision agriculture. So it makes to DBCA, option number B. Next question, RRB AFO 2021. Give answer for this. What will be the answer? Okay, definitely option number B again, precision farming, and that too definition based question. No, that's why even in the previous session I told you in farming system part, definition based questions are very common and important at the same time. Next, IFCO 2025. What is the primary goal of precision farming? Come on, tell me, everyone. What will be the answer? Okay, good. Option number C, optimize input use based on site specific needs. Very good. Next, in remote sensing, which radiation is used for detecting the object? OUAT PG exam 2021. Tell me, what kind of basically radiation is detected? Okay, good. Answer is option number D, reflected radiation. The sensors capture, they detect the reflected radiations. Option number D. Next, in which year the first Indian remote sensing satellite IRS-1A was launched? Tell me the launch year. Very simple question. What will be the answer? Okay, good. Option number B, 1988. Very good. Next. I need correct answer for this question, everyone. What will be the answer? Okay. Option number 4. A is false, but R is true. Now, see this. Assertion says in the GPS, 3 satellites are accommodated in each orbit at an altitude of 20,185 km above the Earth's surface. So first of all, let's talk about this assertion. 3 satellites in each orbit. Assertions is saying this, but we know that total satellites, okay, total we have 24 satellites, and orbits total we have is 6. So how is it possible that each satellite has only 3? Sorry, each orbit has only 3 satellites. Not possible now. So definitely it has to be 4 satellite. This is the correction. It has to be 4 satellite, not 3 satellites. And 20,185 kilometers, C, exact is 20,200 kilometers. So definitely assertion is wrong. Reason? All GPS satellites are placed in the 6 orbits. So if I treat this reason as in a different individual statement, then definitely it is correct. No? Definitely it is correct. Yes, GPS has 6 orbits. So A is false, but R is true. Okay, option number 4 is the correct answer. Option number 4 is the correct answer. Now, first remote sensing satellite in India is JRF Agronomic 2023. Tell me the first remote sensing satellite. Okay, it's option number 1, IRS-1A. Good, and thank you so much. Here we wrap up today's session. Now, PDF, I will be uploading the PDF in the comment section. Okay, I will be uploading the PDF in the comment section, and you can take it and download it from there directly. Okay, done. So I suppose it was nice meeting to you all for the 3rd class, and then next class will be on Monday. Okay, and next YT class will be on Monday on a different topic. Okay, done. Thank you so much, everyone. Let's wrap up this today's session. Like and share it with your friends as well. Okay, bye all of you. Take care. Ending the class.